There's Today we are gonna do some more circuit analysis. If I can get this, I just want to get the YouTube whatever thing that I can watch. It. So I'm starting a bit late today. My microphone wasn't working for some reason. Sorry, you might see in the background my dog is playing with one of her toys, and she sort of just threw it and hit the garage door. Um, yeah. Anyways, let's go there. I'll watch it in the control room here. Yeah, so it is showing me now. Today, I think we are going to go look in this textbook right here, Microelectronics by Horstein. And we're going to do some, uh, what's it called? MOSFETs to start off with. I was also thinking I might go and look at some of these digital ones here because I am actually, where is it? This one here. This SRAM, or like the RAM there, I was actually thinking of looking at it just because I'm going to be doing that tomorrow. But anyways, let's go. Let's look up to T's operational amplifiers. So we're gonna go to 239, I think, in the textbook here. It's 239 field effect transistors. Let's just start. I'll look for a good circuit. Now let's delete these off. Draw active components, MOSFET, and channel one. Okay. Yeah, let's do this one. Um, so this is figure 5.20 on page 250. It has two uh, gates here, or MOSFETs. And let's just see what it would look like. Should have stayed here. Go do this one like this, right there. And draw, add wire, there. There, wire, This one, let's read the question that it asked us to solve with it too. It said in the circuit of figure 5.20, the value V1, and V1 is the value that is in between these two. So I will actually go like this. This will be V1. Here, let's add in a test point. So there's our test point. That's V1. Let's see. Value of V1 will change with Vs. Vs is going to be the voltage we put here at this gate. As we shall show in chapter 6, find the equivalent threshold voltage of QB. That's this one here. So I can actually add. Nope, that's bad connection there. Just thinking if I could. So they show it as ground there, but I think that they people just do that. So this is QB here. So the equivalent voltage when V1 equals 2.5 volts is this here. Oh, my dog's ripping apart one of her toys again. It's 2.5 volts. Assume QB. We have parameters of gamma, half volt, the power of 1/2, theta. Ooh, I forget all that stuff. So basically, what we are looking at is going to be this one right here with respect to this here. Okay. Let's keep drawing the circuit out here. Yeah. And the background. That's there. This also connects over there. I think we got all the connections actually done already. Now we just have to add the voltage sources. So draw voltage source, 5 volts there. Let's stop this here. Put 5 volts there. Edit. And I'll put it at 2 volts. Okay, so what I'm going to say is going to happen here, this is my prediction, is that when I turn it on, this is going to be however much most the voltage drop for this MOSFET is. So say volt maybe. So that's going to be 1 volt there. Let's see. Well, yeah, okay. No, that is. I said that wrong. So I was thinking that a volt drop right here. So that would be 1 volt there. Let's edit this to say 4 volts. And now it's went a bit crazy. Let's go 1 volt. So that's 3.5. Yeah, no, it is varying, but not in the way that I thought it would. Definitely not in the way I thought it would. Hmm. I might look at that later again. But let's. This is all theory. Which maybe I should reread since I seem to not have a very good understanding of it, anyways. Um, you know what we can do? We can do a sweep, I think. So let's go. Oh, one, we'll put this view in new scope. Now we will edit this. Can we do a sweep? No. So let's go here, delete that. We'll stop. Options, draw. I'll put labels, input sources. AC sweep. Okay, let's just see. Edit. That's I want to do a DC sweep. Wave source, voltage source. Noise generator, variable, add variable voltage. What does that do? No. Hmm. Well, I think we will move on to another one here. Already in bipolar junction transistors. Ah, here we go. Yeah. Let's do this one. It's figure 5.81 on page 302. Then I think I might just go to do that SRAM one, but we will see. I'm thinking I might go and I might spend some time just putting together some MOSFETs um, in the not too distant future. So this is a P channel. Because what I was thinking of using them for is my dusk to dawn circuit. I tried to make it with a comparator. Well, I did make it with a comparator. I guess I didn't try, but it's really not um sort of that great on power consumption. So I'm thinking of using a MOSFET instead, like MOSFETs instead somehow. I figured that might be useful because the um like MOSFETs, the main thing that I really take away from them is that obviously their uh input, like the gate current is basically zero, which is what I was thinking when I did the op amp one. But with op amps, especially the older one I was using, I think it's just naturally takes up more power. Like it's not a very low power thing. Which I know I could find ones that are low power. I'm just thinking it might be better, like if I could try to be a bit more clever and deal with it in a more clever way. Just, because cleverness is always good. Mm-hmm. Go there. My dog is back. Hey, bro. Yeah, she's ignoring me now. And here, plus 5 volts, and then it wants us to put a minus 5 volts here. Edit, minus 5. Okay. So, this should set the voltage basically right in the middle, right? 3 volts there. Minus 5 there. Three milliamps. Now if we drop this, guess yeah, the voltage here goes way down. So then the current stops going through. Ah, right. I think MOSFETs all have, what's it called? MOSFET threshold voltage. Yeah. So that's what we have there. I think that also answers my question about what I could do with my dusk to dawn circuit. But we'd have to find a small threshold voltage one. Hmm. But anyways, I think what I've learned now is that obviously I need to learn more about MOSFETs. So let's just see what they were asking me this question. See if I can figure out what the answer would be. No, it has a bunch of words in it that I'm not getting. It's funny. I did do this all, like, I'm looking back in this textbook. I took this course, back when I was in university, so I would have done all of this. But now, I would prefer to just deal with op amps. But if anybody has some questions or otherwise, I would be really happy to answer them. But since there doesn't seem to be very many people around right now, anyways, you know what we can do? Let's go in and look at these. Voltage inverter, current source, current ramp, current mirror, common source amplifier, multiplexer. Let's do this one. So this one what did they call it? MOSFETs, common source amplifier. So there's our output. What it's doing there. Yeah. So it's taken a common source, like so this one, and it's just amplifying it by, that's quite a lot, to the output right here. And like there could be many reasons you'd want to do it. One I would think would be some sort of signal from a radio or something. But yeah, that's cool. Let's go and look at another one too. Switch. Wait. That's just a transistor one. There. Here's a MOSFET switch. There. That's obviously. So we switch this on and then it just gives some signal to the gate. No current, you see? There's no current going in. A perfect MOSFET will have no current going into its gate. Let's go. Source follower. So this is the output. Looks like the current's always going in the same direction. But the signal is changing. So that makes the voltage here change. Let's slow down the simulation speed. So I think it's probably going to go from minus 10 volts. This whole time, the current is going in the same direction. Yeah, it's 2.7 volts. Ah, yeah, it would still go in the same direction because the minus 15 volts is less than the 10 volts or whatever it gets up to. Okay, current mirror. Oh, yeah. This is list your standard current mirror. And let's go. Delete an edge detector. Switchable filter. I want to see a voltage inverter. Oh yeah, it's just switching it back and forth, so. Okay, that's an analog switch. I see. So then we charge this up. So then we got plus 5 volts here. But then we close in on this switch here. So we would charge this to plus 5 volts here in a second. Slow this down. Yeah. Ah, yes. So you see what's happening? You charge this to plus 5 volts, then you connect that side to ground. Then when this closes, you connect that, and then this is minus 5 volts here, which then goes and basically supplies that minus 5 volts there, so it inverts it. And then this is just a clock that, like, it's a square wave generator basically, and then it closes this analog switch, and then it is connected to a NAND gate of sorts. It says inverter, but yeah, and then yeah, I think I get what's going on there. So let's do crystal oscillator. That's this thing here. Cool. I think that's good for that. I'm definitely gonna go and take some time to do a few more. Look at traffic light. What's this? Does that have? Is that a 555 timer? It is. Cool. And this is a counter. Yeah. And the time. Okay, so the timer just sort of pulses its count, and then it goes over to each of these to figure out which one it should turn on. I see. Um, Interactor. It's an LED array. Oh, that's a demultiplexer. Cool. Smiley generator. That's funny. But yeah, um, I actually wanted to see. I don't want more passive circuits. What sequential logic? Ah, here. Let's look at this. Oh, this is a whole actual RAM. Yeah, that's not what I wanted. I don't know. I didn't do much preparation for this one. I've actually been sort of flat out um, working on the labs here. But you know what I think I'll do? Let's go and we will just add this. So, write enable, output enable. Yes, so this, if I'm remembering right, let's add wire. And we will draw a switch too. I just want to see if I can make this work the way that I think it should for tomorrow, because I actually just soldered that on. Where are the switches here? Relay switch. I just soldered one on for myself. And we will do the same here. And the reason I'm doing that is that in the current chapter I'm reading for Art of Electronics is the one on memory. They make a state machine, which I'll also think I'm gonna do, but the way I'm gonna do it is different, sort of, from what they were talking about. Mostly because I don't have the right counter. I have a counter I made, but I don't have the one that they were talking about. I just threw the thing for my dog there. You might see her in the background or hear her in the background playing with the toys. But I'm gonna load up this thing I soldered to sort of just give I'm gonna add some pull-up resistors here to give frick, I don't know how to speak right now. Yeah, that's how I should do it. Go there. This goes like this. Yeah, so I'm gonna load it up. I'm gonna plan to write a program on the like on the Mega Arduino Mega, and then with that program that I'm planning to use, I will load up a bunch of things, and I'm gonna make the counter sort of cycle through them, and then I'll see basically LEDs light up when I want. That's at least my plan. See if I can figure this out though right now. And right there. So now we will draw ground. Let's just see if I can just add a wire for each of these to it. This is really messy, but I think I'll be able to get the idea. And I'll use that for tomorrow. Then draw passive component to switch. Okay. Now, oh, need the switch over there, and get there. Now let's draw in the voltage sources. Just gonna put this stop there. That should be round. Correct. There we go, right there. Now I know these aren't very well drawn up here, but now I'm sort of just wanting to get, so I'm gonna do right enable, then let's that, this, okay, let's start. Ooh, that's not good. Stop. So obviously, let's close this. Oh, oops. Let's see what happens here. Very bad connections. Huh? Oh, there. Yeah, so that didn't work how I thought it would. I'm just gonna end the stream here now. And I will check this out later and see how I'm supposed to do this. And I will let you all know. Thank you.